Okay, this video is about graphing rational functions, and to do this we're going to need to draw upon things that have been talked about recently, which have to do with asymptotes and intercepts, and then getting the overall shape and putting it all together in a graph. So there's 8 steps that I've outlined here that you're going to need to do. First of all, you factor the rational function if it's capable of being factored. Divide out any common factors that exist if possible. Next, identify holes which would be associated with common factors. That'll be clear in an example I'm going to give you in a moment. Third, find vertical asymptotes by setting denominator to 0. Fourth, horizontal asymptotes. That comes from end behavior, and it's based on the largest degree term of the numerator and denominator. 5 and 6 are finding the intercepts, x-intercept y0, y-intercept x0. Then make a table of values outlining the information just found, plus a couple of other points near the vertical asymptote. Lastly, sketch a smooth curve. So I've got 2 examples to run through to show how this works. First up, the rational function x minus 2 over 2x plus 4. Step 1, rewrite it by factoring the 2 out of the denominator. Now, no factors are going to cancel, so I'm not going to have any holes. Holes would only occur when I have common binomial factors that are reduced. So third, I guess we're on to find vertical asymptotes. Okay, vertical asymptotes happen when we divide by 0. So that's when x plus 2 equals 0 or x equals negative 2. Horizontal asymptotes. Horizontal asymptotes have to do with the largest degree term on the numerator and denominator. So I say that y is essentially x over 2x. Those are the largest degree terms, which would simplify to 1 over 2. So my horizontal asymptote is the horizontal line y equals 1/2. The x-intercepts, that's when y equals 0. So I set the rational function to 0. And a fraction equals 0 when the numerator equals 0. So x equals 2, or I can write it as the point 2 comma 0. I want the y-intercept next. The y-intercept happens when x equals 0. So I'm going to get y equals negative 2 over 2 bracket 0 plus 2, or y equals negative 1/2, i.e. 0 comma negative 1/2. Got my x and y intercepts, got all my asymptotes. So now a table of values to summarize some of this. So I will say that, let me see here. I have a vertical asymptote at negative 2, so y is not defined there. I have an x-intercept at 2 comma 0. I have a y-intercept at 0 comma negative 1/2. And now I'd like to find out what's happening near the x vertical asymptote. So I'll try substituting a couple of values near to that, like negative 1 and negative 3, into the original function. Negative 3 would lead to a numerator of negative 5 and a denominator of negative 2. So that's positive 2.5, 5 over 2. Negative 1 substituted gives negative 3 numerator and 2 denominator. So that's negative 1.5, I believe. So I'm going to plot this information on a graph now. Vertical asymptote at negative 2, we make a dotted vertical line. Horizontal asymptote, y equals 1/2, horizontal line. We'll plot the y-intercept, and we'll plot the x-intercept. Then I've got the point negative 3 comma 2.5. So I can see that I have this dotted line behavior in one point, so asymptote behavior is going to look like this, heading towards the vertical and horizontal asymptotes. And I've got the point negative 1 comma negative 1.5. I'm connecting these dots and heading toward the asymptote, horizontally and vertically. That's my rational function. Okay, a little bit more complicated example. This one has a quadratic on the numerator and denominator. So step 1, I might want to factor out that negative just so that I can see a pattern on the numerator a little more clearly. The numerator is going to be factorable into x minus 2, x plus 1, and the denominator into x minus 1, x plus 1. So you'll notice that I have a common binomial factor that I can cancel. So this function is equivalent to negative bracket x minus 2 over x minus 1. Now, that's a simplified rational function. It's not virtually identical to the original one. The original one was a quotient of quadratics. This is a quotient of linear functions. So it's equivalent without being equal. The key difference is there's a hole at x equals negative 1 where I removed the common factors. Now that would be clear in the original function. If I substitute negative 1 into the original function, I get 0 divides 0. But if I substitute into the simplified function, I would actually get negative 1 minus 2 and negative 1 minus 1, which is positive 3 over negative 2. So it's defined on the simplified function, which is actually misleading because it's a hole. It's not defined there. But the whole location can be found this way. Negative 1 comma negative 1.5 is where the function doesn't exist. Now, vertical asymptote, that's when I divide by 0, so x minus 1 equals 0 or x equals 1. Horizontal asymptote, I'm going to look at the largest degree term, which is negative x on the numerator and positive x on the denominator. So I get y equals negative 1 as my horizontal asymptote. Maybe I'll plot those right now. X equals 1, looks like that. Y equals negative 1, looks like that. Okay, let's get the x-intercept. That's where y equals 0. I'm going to use the simplified expression for that. So that's going to happen where 0 equals negative x minus 2, or where x equals 2. The point 2 comma 0. Let's plot it. Right there. Y-intercept when x is 0. So I get y equals negative bracket 0 minus 2 over 0 minus 1, which is negative 2. So it's the point 0 comma negative 2. Plot it right there. Now if I make a table of values to find a few other values, let me see, I've got 2 comma 0, I've got 0 comma negative 2, I have a vertical asymptote at 1. What else might I want to know? I might want to know about 1.5 and 0.5 perhaps. Maybe I'll plot those up here. 0.5 and 1.5. Those are values to the left and the right of the vertical asymptote. So if I substitute those into the original function, I get negative 3 when x is 0.5. I already worked that out before. And I get positive 1 when x is 1.5. So right here and right here. Connect the dots with a smooth curve heading toward the asymptotes without touching or crossing. And the only thing I haven't accounted for that's going to cause me to need to erase is I forgot about the hole at x equals negative 1 comma negative 1.5. So right there, I actually have to write a hole. So I go to it, but I don't go through it. Okay? And if you use a graphing calculator with Zoom 4, you should see that hole. And if I have that set up on my calculator, I will be able to run you through that. Let's see here. No, I don't have it on the calculator. So let me put it in really quickly. 2 plus x minus x squared divided by x squared minus 1. Try Zoom 4. What happened? I must have missed a bracket or something. Oh, I missed the divide by. So I actually made a quartic function. Well, there's a little bit of review built in for you. Let's insert the divide by, and now we get a rational function. There we go. And you'll notice right here there's a little gap. That's my hole at x equals -1. There you go.